next problem based on the factorization. Second problem. So factorization method. Factorization method means this is the process. It is a property. Actually, we call it as a property. Basically, this theorem. There are eight properties to find the determinant of a matrix. Already we saw six properties are over in the last classes. Now these are the I listed out the properties, eight properties. Factorization theorem or factorization property is the one of the important property to evaluate the determinant. Most of the our data science problems, not only in core subject, in your core subject means computer science papers, sometimes we need to evaluate the linear equations. That time it is useful to us if you remember the properties. So one more problem, prove that the det of the matrix equal to 2abc times of a plus b plus c whole cube. We can prove by using other properties also. Here I am applying only factorization method because I am discussing about factorization theorem process. So okay, put x equal to a in the determinant. Here x plus a something is there. Put x equal to a. If we get any two parallel lines, then x minus a is a factor. Suppose if you get three parallel lines, three are same either rows or columns, that time x minus a whole square. If k are parallel lines means they have the identical values. Then x minus a whole power k minus 1. 2 means x minus a. 1 is less than. Two lines are parallel, then x minus a is factor. Three lines are parallel, x minus a whole square is the factor in the determinant f of x. In the f of x, x minus a is the factor. This is the way to apply the factorization method. Now, this problem, second problem in the factorization method. Now, already answer is also known to us. Usually, we apply the factorization method when you know the answer also. In the right hand side, we have a factors a, b, c, a plus b plus c whole cube. So we know the all factors. So it is better to apply the factorization method. You can apply other method also as your wish, but my suggestion is already we know the factors in the right hand side. Answer is also known. LHS is known to us, RHS is known to us. So one thing only we find what 10 is known. Okay. Sorry. Now okay. So in this problem, already RHS also known to us. So it is better to apply factorization method. You can apply other properties also. My suggestion is it is better to apply factorization method. X minus a is a factor in the RHS. If x equal to, by substituting x equal to a in the determinant LHS, we get a two parallel lines. That means we have a same values in the two lines. Either columns or two rows are equal. Then x minus a is a factor. Here a is a factor means you understand that a equal to 0 is a factor. That means our first step is put a equal to 0 in LHS. Consider LHS and so that RHS. Take LHS and prove that RHS. In LHS, put a equal to 0 because RHS we have a is a factor. That means in place of x we have a, in place of a we have a 0. That means a minus 0 is a factor. A minus 0 means a. Put a equal to 0 in LHS, then the determinant becomes b plus c as is whole square. A becomes 0 square. 0 square means 0. A square 0. Second row b square. C plus 0 square means c square. B square. Third row c square. Sorry. C square. Then b square. Is there any two parallel rows? Yes, we have a two parallel rows. What are the parallel rows? Can you anyone guess? So second column and third column are parallel rows. Even the entries are different because we take a common factor c square. Here we take a common factor b square. Then it becomes c square, b square. Usually we get a parallel lines b plus c whole square 0 0 b square 1 1 c square 1 1. So you understand that these two columns are parallel. When this happened by substituting a equal to 0, two parallel lines, two columns are parallel or two rows. Here columns are parallel. So therefore, as per our factorization method, a is a factor. A is a factor. How many times, how many columns are parallel? Two columns only. Therefore, x minus a, x means a. A minus 0 is a factor in the RHS, factor in the RHS. Similarly, we can proceed. Similarly, mm, similarly, substitute another factor. You observe that in the RHS, b is also a factor. Don't think about c square, b square common. So our intention is how many rows are parallel or how many columns are parallel. So here two columns are parallel after substituting a equal to 0. Now b is a factor. Substitute similarly put b equal to 0 and c equal to 0 in LHS. In LHS, we get a two parallel. We get because b equal to 0. What happened? B square. B equal to 0 means first row c square, a square, a square, 0, c square, c plus a whole square, 0 square, 0, c square, a square. Previous, just like previous time, you take a square and b c square from common, we get two columns are parallel when we substituting b equal to 0. Therefore, b is a factor. We get b and c are factors. Now, totally, how many factors are there for the RHS function? Three factors. One is A, another one is B, another one is C. Total three factors are there. That means A, B, C, okay. Okay, it is better to solve the problem uh, below. Actually, I typed these questions. I will try to down this one. space is enough. So now three factors over. Next another factor is a plus b plus c whole cube and 2 additionally is there. So other three a b c over other how many factors are there? A plus b plus c whole cube and 2. So now our intention is put a plus b plus c equal to 0. Next point is put a plus b plus c equal to 0. That implies b plus c becomes minus a. Substituting b plus c equal to minus a in LHS, then we get, you observe that data in the first row, b plus c value becomes minus a whole square. Next element in the first row is a square, next element a square, you see in the given hypothesis. The second row, b square, c plus a becomes minus b square, c plus a. Keep c plus a one side and b another side. C plus a become diagonal element, you substitute. So b square, next element minus b whole square, b square. You observe that second row. Just only I am substituting diagonal element. A plus c equal to minus b, and next diagonal element is a plus b equal to minus c in the third row. We can use this substitution. How many rows are identical or how many columns are identical? Can you able to guess it? Take a square is a common from the first matrix, first row, not matrix. B square is a common factor from the second row. C square is a common factor from the third row. Therefore, after taking common factors, the matrix become 1, 1, 1, 1, 1, 1, 1, 1, 1. How many identical rows are there? Three identical rows or three identical columns. Therefore, how many times this is a factor? A plus b plus c whole square is a factor. 3 times means exponent 3 minus 1 is a factor in the determinant value. Okay. Now, one more time we down this one. But in RHS, we have a plus b plus c whole cube. Other factor also there. Here we get only square. So A has a degree 1, B has a degree 1, C has a degree 1, A plus B plus C has a degree 2. So, but in RHS, in the determinant expansion, Laplace expansion method, the total degree of the variables is 6 because B plus C has 2. In the determinant, we usually cyclic order. First row, first element, second row, second element, third row, third element, first row, second element, second row, third element, third row, first element, like that. If we add their total exponent, it becomes 6, but we get up to 5 only because a plus b plus c whole square 1, here a1, b1, c1. So another factor is a plus b plus c is missing. So here the total degree of the variables is 6, but the obtained degree is 5. Is 5. A, B, C, A plus B plus C whole square. Now add A1, B1, C1, A plus B plus C whole square. Total degree 5. Up to now we get 5, but total degree in the determinant expansion is 6. So other factor missing is, therefore this det value contains k times of a plus b plus c is another factor. What is our problem? B plus c whole square, a square, b square, c plus a. Okay, now b plus c whole square, a square, then b square, a plus c whole square, b square, c square, and what is this? A plus b whole square. In the determinant, k times of, because balance k is constant is there. So already a, b, c, a plus b plus c whole square is, we get. Remaining balance is, we need to show that k equal to 2, another factor b plus c is also a factor, because the degree is 5, but the total degree in the expansion is 6, is also a factor. Now find k value. It is better to substitute a, b, c value in the left hand side. We get a k value. As your wish, you take all values are same or different values. Put b, c, which one which way is better. Don't take all our zeros. If you take all our zeros, so that is 0, we can't find a k value. At least you take one or two non-zero values. By substituting, put a equal to b equal to c equal to 1. Then the determinant becomes 2 square. This is because to find c value, a plus b plus c is also one of the factors, because the degree is 2. All are symmetric. A plus b plus c is a common factor. Why? Because these are the symmetric in nature. C, symmetric. B plus C, A, then B, A plus C. They change the nature cyclic order symmetrically. So therefore, A plus B plus C is another factor. So for finding K, we choose the values. A equal to B equal to C equal to. Here I am choosing A equal to B equal to C equal to 1. Don't take all are at a time zeros. So here 2 square, not 2 square. 1 square means 1. 1. Then here 2 square, 1, 1. Here 1, 1, 2 square equal to k times of 3. K times of a plus b plus c, 1 plus 1 plus 1 means 3. Now expand the debt as your wish. That if you have a difficulties, uh, you apply the any properties, or directly you can apply the Laplace expansion as your wish for finding debt value. But our intention is, it is better to apply factorization method when you have a LHS and RHS values. 4, in the expansion it becomes 4, 4 into 4, 16 minus 1. I'm expanding first using first row. 4 minus 1 plus 1 into 1 minus 4. 1 minus 4 equal to 3 into k. What about simplification value? 3 into k. 16 minus 1, 15. 15 into 4. 15 into 4, 60. 3. Minus 3 into 3k, which is equal to 16 minus 6 means 54. I made some mistake. Somewhere I made a mistake, I think. Otherwise, We did not get a 2. Yes, yes. One mistake I made here. Don't along this other factors also there. A, B, C into A plus B plus C whole square is also factor. This is also a factor. So here we get 3 times A1, B1, C1 and 3 square. 1, 1, 1, 3 square. Now it becomes 3 into 3, 3 into 3 into 3, 27. So in the left hand side, in the right hand side, we have a value 27. 6 equal to 27K. That implies 54 equal to 27K. That implies K equal to 54 by 27.
So first problem, matrix multiplication method. So last property of the determinant, multiplication of the determinant. Here they provide the two determinant. One is 3 by 3 order, next one is 3 by 3 order. Find or evaluate this value. Evaluate this value. The evaluation process, already we know, first row, first row, first row, second row, first row, third row is the first row of the resultant matrix. Now let this product, suppose this is say D1, this is say D2. Now we required their product. Now we required their product, D1 into D2. D1 into D2. D1 into DT. Resultant is also 3 by 3. This is 3 by 3, this is 3 by 3. So resultant det is also 3 by 3. First row, first element, say D11. Later we find the value. First it is better to represent in this manner. Next element is D12. Next element is D13. First row over. Next row is, second row means 21. D22, D23. Second row over. Third row, D31, D32, D33. Now we don't know D1, D12, D23. But we know the procedure how to evaluate the D11. D11 nothing but first row of the first matrix multiplied with sum of the product of first row of the first determinant with the first row of the second determinant in the corresponding order, same order, first element to first element. So D11 value is, our D11 value is now a square plus lambda square, a square plus lambda square into lambda first element plus second element into second element. Second element of the first row is AB plus C lambda into second element of the first row is C. C plus third element CA minus B lambda into minus B. Simplify this expression. A plus B into C formula. This is nothing but A square plus B square into lambda. Okay. Put lambda into lambda plus ABC plus lambda C square plus CA into B minus, here plus is there, here minus. So minus, remove this plus symbol, remove this plus symbol. Okay, it is better. So in place of plus, you take minus already. If you have any confusion, write down. Minus so bracket minus ABC, minus into minus plus B square lambda, minus ABC plus ABC get cancelled. Finally, we get here B lambda, see CA minus B lambda into lambda, B lambda into here, what is this, lambda or B? 1 minute. B minus B. Okay. Okay. Minus into minus B square. Somewhere we get a here lambda square into lambda, not B. In this term, lambda square into lambda, not B. This is a lambda. So 1, 2. In the first term, we have lambda into A square. Second term, lambda square into lambda. Third term, lambda into C square. In the last term, B square into lambda. Take lambda as a common factor. We get lambda times of A square plus B square plus C square plus lambda square. Okay. Similarly, you can evaluate. We get D12 equal to 0. D12 equal to 0. D13 equal to 0. D13 means first determinant of first row, third determinant of the second det, third row of the second det. D12 means first row of the first determinant, second row of the second determinant. So except diagonal, all elements, all entries, except diagonal, all entries should be 0. If you apply the same logic to D22, nothing but lambda times of, in the examination point, based on the marks, you need to prove. If they provide, suppose 8 marks, we must prove the proof for all this one. 2, 3 equal to 0, 3, 1 equal to 0, D 3, 2 equal to 0, D 3, 3 equal to lambda times of A square plus B square plus C square plus lambda square. Therefore, their product, therefore, the product delta 1 into delta 2, nothing but, so first element is D11. D11 value is lambda times of A square plus B square plus C square plus lambda square. Next element is 0. Next element is 0. Here 0. The second element of the second row is lambda times of A square plus B square plus C square plus lambda square. Lambda square. Last element 0. Here the last row 0, 0. Lambda times of A square plus B square plus C square plus lambda square. Det close. Further, more we can simplify, because in the first row we take this element common, second row we take this element common, third row we take this element common. Finally, we get, in the first row you take a common lambda times of A square plus B square plus C square lambda square. Here we get 1. That means we divide with lambda plus lambda times of A square plus B square plus C square plus lambda square by the first row. Here 0 by lambda times equal to 0 by something equal to 0, 0 by something equal to 0. So first one 1, second one 0, third one 0. Similarly, in the second row, you pick this as a common factor. Already lambda is there from the first row. Now lambda square. A square plus B square plus C square plus lambda square already is there from the first row. So it is square. Likewise, you do, take common from all the rows. Sorry, here 0. Here 0, 1. 1. But in each row, lambda is coming from 3 rows. Lambda cube is a common factor. This is lambda cube. A square plus B square plus C square plus lambda square whole cube. So other part of the det is identity matrix of the determinant 1, 0. If we expand this determinant in the by using first row or any row, because other two rows or zeros, we get 1. So this value becomes this one only, because this det value is 1. Det of this value is 1. If you expand by using any row or column, lambda cube A square plus B square plus C square plus lambda square whole cube into 1. If you expand this det, we get 1. 1 first row, 1 times of det of already you know in BSc level. I don't want to teach too much about the determinant. So no need to put here 1 into 0. Det of this value is 1. You write down in the braces. It is better in the examination point of view. It is good impression for on you. Okay. So that means lambda cube 1 into something equal to same value. Lambda square plus C square plus lambda square whole cube. This is first problem in the not factorization, product method. Next problem in the factorization is, my suggestion is you must learn three problems, at least three problems in each topic. Next problem here. Okay, next problem. So capital letters denote its cofactor. Cofactor means removing corresponding row, corresponding element of the element, and find the det and multiply with -1 whole power. I value, I means row value plus j column, ith plus jth column. So here this is the det of the matrix whole square. We need to show that this det value equal to this one. So usually important problem. All are important. Anyhow, it is a tricky problem. You must remember these things. Cofactor. We know that in BSc level, all these things already you learn. That's why I am telling you briefly. We know that corresponding row of the cofactor. So first row A1 indicate the A1 determinant cofactor value. B1 indicate the B1. Corresponding cofactor and corresponding elements sum equal to det of the value. Det denote the det nothing but A1, B1. Usually det of the matrix or det of the arrangements. This expression is denoted by A1, B1, C1, A2, B2, C2, A3, B3, C3. Usually denoted by det. Now we want to show that this value equal to this square. Here take LHS, we prove RHS, or take RHS, we prove LHS is difficult. So one more time, we assume that let delta dash equal to LHS value. A1 cofactor of the elements. A1 cofactor. A1 cofactor means cofactor of A1. Cofactor of A1. A1 means which is equal to -1 whole power. This is denoted by capital A1. Capital A1. -1 whole power. A1 in the first row. Row value plus column value, first column, into det of removing its corresponding row and corresponding column and find the det of the remaining. Det of the remaining is B2, C2, B3, C3. This is nothing but A1. Similarly for others, other entries. This is the cofactor, etc. B1 indicate the corresponding B1 cofactor. C1, capital C1, not small c1. Previously, we have small, here capital B2, sorry, A2, B2, C2, A2, B2, C2. In this matrix, we have a capital letters. A3, B3, C3. Now multiply delta dash into delta. Delta dash into delta. Row by column. Row by row, not row by column. In matrix multiplication, row by column. Det multiplication, row by row. A1, capital A1 into small a1, capital B1 into small b1, capital C1 into small c1. Next entry is capital A1 into A2, capital B1 into B2, capital C1 into small c2. Next entry. Last entry of the first row is A1 into A3 plus B1 into B3 plus C1 into C3. Det. Next row, second row. Second row means second row of the first matrix. A2 into A1 plus B2 into B1 plus C2 into C1. I write down all the things. First columns A3, A1, B3, B1, C3, C1. Second column A2, A2, B2, B2, C2, 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 C2. This is A3, A2, B3, B2, B3, B2, C3, C2. This one A2, A3, B3, sorry, B2, small B3, capital C2, small C3. Last row A3, A3, B3, A3 plus C3, C3. By the determinant property, this value, sum of the cofactor of the element and its corresponding elements is nothing but det. So this value nothing but det. This value gives the det of the first matrix. This value nothing but det. Sum of product of the cofactors and other any row value becomes 0. So this is 0 because here cofactor of A1 but multiplied with A2 element, not with the same element. So this det value gives 0 with opposite value. Other rows 0. Similarly, in the second row, this gives the sum of product of the cofactor corresponding det value. So this value corresponding element value. This value gives the det. Other values with opposite. That means cofactor of one row elements with other row element. So this sum becomes 0. So in the third row, 0, 0, det. But our intention is del dash equal to LHS equal to RHS. So here also almost we are reached our goal. In the left hand side, we have del dash del. On the right hand side, you observe that first row we take del dash, second row we del, second row del, third row del, total del cube. The det 1 0 0 0 1 0 0 0 1. Det of the identity matrix equal to 1. So det of this is identity matrix of 3 by 3 order. Det of identity matrix equal to 1, always 1. So this value is 1. No need to expand, no need to expand. Just if you have any time, you expand in the examination. Our intention is, so 1 del, here 1 del. So it is so it is better to write down. One del, left hand, right hand side 1 del. So finally we get del dash equal to del square. Del dash means determinant of the cofactor matrix equal to del square means the determinant of the corresponding matrix, corresponding entries. So finally we get del here del square. So that is del dash del equal to del cube. Del dash del equal to del cube. So cancel out del from both sides. We get del dash equal to del square. Del dash equal to del square. That is determinant of cofactor matrix B1 A1 B1 C1 A2 B2 C2 A3 B3 C3, which is equal to A1 B1 C1 A2 B2 C2 A3 B3 C3 whole square. That's all. Last problem. Last one is very tricky. We can't guess it. By the guessing, very difficult. How to guess this problem? You can expand. Blind method is Laplace expansion method. If you have a here, RHS is as the square of a determinant. Square of a determinant. So square of some other matrix, like previous one. Previous one LHS is a determinant of some matrix. RHS is square of some determinant of some other matrix. Likewise, we need to expand for this matrix also. So last problem in this topic. There are many problems in Gravel textbook. Gravel is the your prescribed textbook. If you have any interest, you can follow the Gravel textbook. Each model you must practice at least 2 to 3, minimum 3 problems. So I am covering different problems. Same type of problems are there in Gravel textbook, or you can follow Crazy also. So here our question is, expand this as the square of a determinant of some other matrix and hence find its value. Later find the value. Two questions are there here, not a single one. Okay, we will try. In the diagonal only we have two terms. In the other one only single term. So suppose say this value is del 1. It is better. We say this value is a del or del 1. So say this value equal to del 1. Say in the examination point of view, you write down every step because you need marks. I give the notes briefly. Try to expand properly in the examination point of view. Answer del 1. Please listen, very logical. A, write down A into something, B into something, plus C into something. Okay, C into something. Here also write down. All rows write down same thing. I will give a clarity. In the second row also BCA, cyclic order, B into something, second row. The first row all are same. I give, I mean, we will see which value is there in the braces because we have a value 2BC BC minus A square in the first row, first element. So after substituting this braces, finally we get, we want to get this value. Likewise, we need to substitute. In the second row, first row, second element is also same thing. Put like this, braces. Into something. Last row also same thing. A, B, B, C into something. Det close. Here screen is end. Very difficult. So anyhow, otherwise I remove and write down one more time. It takes too much space. Okay. Okay. Answer del 1 equal to A, B, C into something. You write down the first row same. In the braces, we fill the values such that we get the our given det value. Later you realize that how to write down this one as a product of two matrices. Similarly, in the second row, you start from B, A, B, C, cyclic order. B, C, A. Okay. BCA. The last column cyclic order. After A, after B, after next one C. You start from C. CAB. CAB. In the braces, we need to fill the values such that the resultant value is the same as the given det one, because we equate these two. What can anybody guess? In the first substitution, we have a square minus a square. So here we substitute minus a. The second row, B C 2BC. So here substitute C. Here substitute B. Here A is not there. So we need to cancel. C square is there. So put in the braces C at that time, at that place of C, we put C. C into C, C square. Here we need to cancel these two. These two. So here put minus B. Minus B. Here A. Minus AB plus AB. Next, last one. Here we have B square. At the place of B, we put B in the braces. Here we put minus C. Here put plus A. So now we get the first row of the given del 1. If you simplify this, we get the first row. Similarly, at a place of C, we put C. C into C, C square. But these two are not there. So now substitute this value is minus A here at the time of whatever is there in the first within the braces of the first row, you replace in the same in the bottom also. Minus A C B, because in the first row also we have same values. If you substitute, we get the same value. Here C, then B. Okay. Here C, here B. Now what about this? Same thing. Substitute the above braces values only. Minus B, A, C. Minus B, A, C. Here minus B, A, C. Minus B, A, C. Here previous braces value. Minus C, minus C, B, A. Minus C, B, A. Here minus C, whatever is there in the minus C, B, A. Now you observe that it is a product of two matrices. Two det, not matrices. Usually I am using word many times, matrices. Det of first row A, B, C. First row of the first det is, second row of the first det is B, C, A. B, C, A. Third row is C, A, B. First det value over into det of minus A, within the braces values. First row value is minus a CB. In this always using minus a C B. In the first column we use within the braces minus a CB. In the second column we use minus B AC. The third column we use minus C BA. 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 We are happy. But our intention is now we get the product of two determinant. But our goal is to show that it is a square of a determinant. Square of a determinant means both values are same. So further we need to simplify. Keep first one as it is. In the second one, take a minus 1 as a common factor from the first row. A, B, C, C, A, B, B, C, A, B, C, A. Even though it is not a square of det, because here second column, third column, observe that. In the second one, observe that they are interchangeable. So now in the second det, we interchange the third row and third column and second column. We get the first det. So by interchanging the two parallel rows or parallel columns, parallel lines, simply say that we get a minus sign. Already minus is there, minus into minus plus after interchanging rows. Here we have two tasks. First task is so that it is a square of a determinant. Second task is evaluate the determinant value. Now you observe that these two det values same. Minus 1 whole square means plus 1. A into A means A square. So this value nothing but A B C B C A C A B whole square. Whole square. So one part is over. One part is over. Next value is we need to expand the det value. So expand this det value and take a square on both square. We get the det square. Up to this, okay. LHS equal to RHS. We want to show that the square of the det value. Given det value is written as square of some det value. Cyclic order ABC, BCA, CAB. Okay. Now we want to expand. Let delta equal to, we need delta square. ABC, BCA, CAB. Evaluate this det value. As your wish, it is better to apply Laplacian expression. If they ask any specific method, first row element into det of CAAB minus B times of BA CB next C times of BC CA BC CA. Now expand this det value, we get a times of CB minus a square minus b times of b square minus AC plus c times of AB minus c square. Now, if we expand this expression, we get A, B, C, first term minus a square, a cube minus b cube plus ABC similarly plus ABC minus c cube. ABC minus c cube. Now, ABC is 3 times, so this value is 3ABC minus of a cube plus b cube plus c cube. That's all. This is del, but we require del square. So take a square on both sides. Therefore, del square nothing but ABC BCA CAB whole square equal to 3ABC minus of a cube plus b cube plus c cube whole square. That's all. Okay. These kind of problems are there in the factor multiplication of the matrices. You practice some more problems, we get more practice. By the practice only we can solve easily. Otherwise, it is difficult. This is the first part of your unit module 1. First part is determinant is over. There are 8 properties. Sometimes we evaluate the determinant by using more than one property also. Sometimes one property is enough. So as your wish in the examination point of view, they may ask particular method. That time we apply the particular method. Along that particular method, you can apply other methods also. Otherwise, as your choice, whichever method you apply. Basic elementary definition is Laplace expansion. Find the determinant by the Laplace expansion of the determinant. Okay, here I am stopping the concept. It's enough for the first part of the problem.